All right, let's talk about that moment. You know the one. That feeling of dread right before you hit send on a print file. Today, we're going to turn that anxiety into absolute accuracy. We're going to make sure the design you fell in love with on your screen is the exact same one you hold in your hands.
Because we've all been there, haven't we? You pour your heart into a design. It's perfect. The colors pop, the layout is sharp on your monitor. And then the box arrives from the printer, and your heart just sinks. The colors look washed out. There are these weird, thin boxes around your shadows, or worse, some of your text is just gone. It's a classic, gut-wrenching story for designers. So what's really going on here?
To figure this out, we're going to walk through a 5-part game plan. First, we'll look at where things go wrong. Then, we'll build a modern blueprint to prevent those errors. We'll learn how to give the press specific instructions, get a handle on how ink actually works on paper, and wrap it all up with a pre-launch checklist that'll save you every time. Let's do it.
Okay, so first up, let's talk about this gap. This huge, frustrating gap between the world of glowing pixels on your screen and the physical reality of ink on paper. This is the danger zone, where all those classic print nightmares happen.
Now, here's the most important thing to get straight. This is not a failure of your creativity. It's a technical problem. It's a communication breakdown. Your file is essentially speaking one language, the language of digital design, and the printing press is speaking a completely different one. And when those two don't translate correctly, you end up with costly and honestly, totally avoidable mistakes.
So how do we start translating correctly? We need a better blueprint, a smarter one. And that means it's time to let go of some old habits and embrace a file format that was actually designed for how printing works today.
And that new best friend is PDF/X4. Let me show you why. The old way, PDF/1A, basically took a sledgehammer to your design. It flattened everything, forcing all your layers and cool transparency effects into one single layer. This is what causes those horrible little white lines or boxes around objects, what we call stitching. But the modern standard, PDF/X4, is so much smarter. It keeps your transparencies live, and it intelligently manages all kinds of color spaces, not just CMYK. This gives the printer way more control and dramatically lowers the risk of something going wrong.
And if PDF/X4 is the smart car taking your design to the press, the output intent is its GPS. Think about it. It's a tiny bit of data you embed in the file, an ICC profile that tells every single machine that touches your file, hey, this is the exact color destination we're all driving to. It could be Grackhol for a US job or Fogra for a European one. This little setting is probably the single most powerful tool you have for making sure your color comes out right.
Okay, so our file is smart and it knows its color destination. But what about all the stuff that isn't actually part of the printed artwork? You know, like the lines that tell the machine where to cut or where to put that glossy varnish. We need to give the press instructions for those things too.
And we do that using something called processing steps. Just think of them as stage directions for the printing and finishing machines. Your main artwork is on one layer. That's what gets printed. But then you have separate layers for the dye line or the spot varnish, and you flag those as instruction layers. This tells the machinery, hey, don't print this. This is a guide for you to cut or to apply a special finish. It's how you separate the art from the instructions.
This brings us to a golden rule. You have to burn this one into your brain. Never, ever try to print white ink by just making a white object and setting it to overprint. It sounds logical, but it will literally vanish on the press. The right way, the only way, is to create a special spot color, name it something like white, put all your white ink elements on their own layer, and then tag that layer as a processing step. This tells the press to physically lay down a layer of opaque white ink. One way is a clear instruction, the other way is a costly mistake.
All right, now let's get into the physics of it all. We have to understand how ink actually behaves when it hits a sheet of paper. And that really comes down to two big ideas: overprint versus knockout, and something called your ink budget.
Okay, so knockout is the default. When you put a yellow circle on a blue square, the software automatically knocks out or cuts a hole in the blue layer so the yellow ink can print directly on the paper. Makes sense. But sometimes you actually want to overprint, which means printing one ink directly on top of another. The classic example is small black text on a color background. Overprinting it prevents any ugly little white gaps if the press plates are a tiny bit out of alignment.
The key is to open up your Output Preview tool in your design software. It's the only way to see what's really happening, and catch things like white text that's accidentally set to overprint, which, as we know, will make it disappear.
Next up is our ink budget. The technical term is total area coverage, or TAC, but ink budget is the perfect way to think about it. Paper is like a sponge. It can only soak up so much liquid, so much ink in one spot. If you go over budget, the colors get muddy, the ink won't dry properly, and you get a smudgy mess. Every paper stock has a different ink budget you have to stay within.
So what does this budget look like in the real world? Well, for a very common European standard for coated paper, FOGRA 51, that limit is about 300%. That means if you add up the percentages of cyan, magenta, yellow, and black ink in any one spot, it cannot go over 300.
And this is precisely why there is no such thing as a one-size-fits-all recipe for a deep, rich black. The popular U.S. standard, Grackle, has a slightly higher ink budget, around 320%. FOGRA 51 is lower. So you see, the formula you use to build your rich black has to change depending on the printing standard. So what's the big takeaway? It's simple. Don't guess. Just ask your printer what rich black recipe you should use. They'll tell you.
Okay, we've covered a lot of ground. We've got the concepts down. Now it's time to put it all together into a final safeguard, a pre-launch sequence that you run every single time before sending a file out the door.
And we really have to change how we think about this. Pre-flighting a file isn't some boring chore you have to get through. It's what professionals do. A pilot runs through a final cockpit check before every single takeoff. They don't skip it because they're in a hurry. As a designer, this is your cockpit check. It's how you catch problems when they're still free and easy to fix.
So here it is, your final checklist for a perfect print file. Let's run through it. 1. Export as that smart PDF X4 and make sure you've set the correct output intent. 2. Tag your dye lines, your varnishes, your white ink layers as processing steps. 3. Use that output preview panel to hunt for any overprint mistakes. 4. Double-check that your rich blacks are within that ink budget, that TAC limit. 5. For any small text, make sure it's just 100% black, not a mix of 4 colors. And finally, number 6. Automate all of this by running a standard preflight check like the GWG 2022 profile. You do this, and you're clear for takeoff.
So I want to leave you with this one question, because it changes everything. Is the file you're sending to the printer just a pretty picture, or is it a complete set of manufacturing instructions? Because a truly professional print file isn't just a piece of art. It's a precise, technical blueprint for a very expensive machine. And when you start thinking like a manufacturer, that's when you really, truly master the art of print.